Alright, in this video we'll talk a bit about external angles. And we're going to be referring quite a lot to some polygons that we already know. For you to understand most of the things that we're going to say in this video, you'll need to watch the video before on angles in polygons. So it might be worth having a quick look at that, because at some point I'll be referring to a formula I used in that video. But let's talk quickly about external angles. Well, you think of the word external, you think outside, yes. And external angles in polygons are formed when you extend a side, any side of that polygon. So here I've got a triangle, it's an equilateral triangle. So I'm going to extend one of the sides to make myself an external angle. So there's an external angle I've made there. I'll show you where the angle is. The angle is just here. So this angle is called my external angle. Now, just the same way, I can extend another side, thereby making another external angle. And last of all, extend this side, thereby making yet another external angle. So those are my three external angles I've got here. That's one, that's two, this is the other one here. Angles made on the outside. I hope you noticed that when I made my external angles, I didn't go against what I was doing. Like, for example, I started this external angle going this way. It only made sense to carry on that way and that way. I didn't. And I'll do this in a different color because I want you to recognize that it is incorrect. I didn't decide that I'm just gonna pull a line this way and then do an external angle that way. There's a reason why I didn't do that, and that's because when we start looking at the polygons on the next page, you will need to make sure that you are using the same direction. Okay, so we definitely don't want that, so we're just gonna rub that out. Okay, we want our external angles all going in the same direction, like so. All right, that's fantastic. Hope you got the idea of external angles. Now, time for us to look at a situation here. Now, here I've got a table you've seen before in my previous video. I've got shapes going all the way to a decagon, number of sides, the sum of all the angles in that shape, or sum of all the interior angles, the size of one of my exterior angles, the size, of one of my interior angles, the size of one of my exterior angles, and the sum of all my exterior angles. So there's quite a lot of work to do here. Lucky for us, if you've watched the other video on angles in polygons, then you should know some of these answers already. But let's get to work. So, for example, here from my equilateral triangle, what I'm going to do is I am going to extend the sides like so. That one looked a little bit funny. So a little bit up like that and a little bit down this way, thereby making an external angle there, there, and there. Well, what I already know about equilateral triangles is that all of the angles inside are the same. They are all 60 degrees. And what I also know is that if I've got a straight line, which is what I would have here, then all the angles that are on a straight line add up to 180 degrees. I'm going to write that below here because that's good to remember. 180 degrees is what it should add up to. So far, I've already got 60 degrees. So the question is, what is missing? Well, what's missing from here is 120 degrees, because when I add my 120 to 60, I get 180. So here I've got some information already. I already know it's a triangle, it's got three sides. All of the angles inside add up to 180. One of my interior angles, because I used an equilateral triangle, is going to be 60 degrees. I also know that one of my exterior angles should be 120 degrees because I've just calculated it over there. And last of all, well, I haven't calculated my exterior angles. I'm going to do that now. So here I've got 120 degrees there again for that exterior angle, and 120 degrees for this here again for that exterior angle. If I add up all my exterior angles, as in add that 120 plus that 120 plus that 120, I will end up with an answer of 360 degrees. All right, that's good. Now let's go to our quadrilateral. What I'm going to do is I'm going to rub this out to make a little bit of space for myself. Just make sure I'm not running into problems. So here we go. I'm going to make some external angles again. So here would be one. That would be one going up there. This would be one going across there. And this would be one coming down here. What I know about my quadrilateral, since it looks pretty much like a rectangle, I know that all of my angles inside are going to be 90 degrees. You can already see that. Because that's a straight line, because that's a straight line, then I know that that's going to be 90 degrees again, 90 degrees again, 90 degrees, and 90 degrees, because on a straight line, I will have 180 degrees. All right, let's fill in the table for a little bit now. One other thing before I fill in the table. I know that because that's a quadrilateral, if you looked at my video on angles in polygons, I know that all the angles in this shape adds up to 360 degrees. So that means I can fill this in and say that all the interior angles add up to 360 degrees. Because I expect all of my angles to be just about the same on the inside, if I divide my 360 by 4, then it's going to tell me that all of my angles will be 90 degrees. So it means that my interior angle is 90 degrees there. I've already worked out that my exterior angle is also 90. So I'm going to write that in now. Exterior angle is 90 degrees. And last of all, when I add up my 4 exterior angles, 1, 2, 3, and 4, it gives me, again, 360 degrees. All right, I know what you're thinking. You're probably starting to make some assumptions, but don't start making the assumptions yet. Let's do a little bit more work first. Here is my pentagon, and on my pentagon I'm going to make some exterior angles again. That's 1, 2, 3, 4, and 5. As you can see, they're all going in the same direction again. And my pentagon, I'll start filling my table out. It's got 5 sides. And because I know it's got 3 triangles in it, I know that this is going to be 540 degrees. If I add up all the angles in my pentagon, it's going to be 540 degrees. The next thing that I need to know is what would be all of my angles, my interior angles in that pentagon. Well, it's got 5 sides. It's a regular pentagon. So all of the angles should be the same. I'm going to divide it by 5 because it's got 5 sides. And that tells me that all of my angles inside this pentagon will work out to be 108 degrees. 108. So all of them are going to be 108 degrees. Well, that's important to know because now I can jot down that 108 degrees in here, 108 degrees. Now I need to work out what my external angle is. This is my external angle on the outside here. So I'm just going to draw it in and try and work it out. So here's my external angle. Let's extend this line a bit more. Well, that's a straight line. This is a straight line here, which means all the angles add up to 180, as we know. So since that's a straight line, all I need to do is subtract 108 from 180, and that gives me 72. So it tells me that all of my external angles are 72 degrees. Okay, 72 degrees. Okay, so let's put that 72 degrees in my table. External angle is 72 degrees. Now that I know that, I can now add up all my external angles, 72 plus 72 plus 72 plus 72 and plus that 72, and believe it or not, it adds up to 360 degrees. Well, if you haven't made that assumption yet, make it now. All of these angles here, the external angle of any polygon, when you add them all up, you're going to get 72 degrees. Okay, now the rest of this table needs filling out, and I'm going to start you off by saying that in this hexagon all of the angles add up to 720 degrees. Could you now go and work out what all of the angles inside this hexagon is going to be? You can pause the video here and work it out. Alright, did you get 120 degrees? Well, I hope you did. If you got 120 degrees, then we can start filling this table out. We can say a hexagon has got 6 sides. All of the angles in it adds up to 720 degrees. One of the interior angles is 120 degrees because you would have divided your 720 by 6 to get your answer. Okay, now since I know that, I can have my external angle worked out as well. Taking away 120 from 180 will give me 60 degrees. So I know that the external angle is 60 degrees, and we've already decided that all the external angles will add up to 360. Now what I'd like you to do is pause the video here, see if you can figure out the heptagon, octagon, nonagon, and decagon. Number of sides, interior angles, what do they all add up to? If you don't know how to do that, you will need to have a quick look at that video on angles in polygons, then work out your interior angle, exterior angle, and see where we get to. Pause the video here now and then have a go at that, and then when you finish, hit play and I'll put all the answers up for you. Alright, so here are your answers. So I hope you got all those answers that we've got there, and you're quite happy with that. Now, what if the number of sides on the shape increased? How can I work that out? Well, we've learned from the last video that if I needed to work out the sum of all the angles in my shape, we've learned that we just need to do 180 times n, which is the number of sides, take away 2. Now, let's just say I want to work out one interior angle of that shape. Well, I already know that all of the angles added together is governed by this formula. Well, if all of the angles is governed by that formula, we got our answer here by dividing by the number of sides the shape had. So, for example, let's go all the way back to the top. 360 divided by 4 gave us 90. 540 divided by 5 gave us 108. 720 divided by 6 gave us 120. So if I've got an n-sided shape, it's an n-sided shape, then that formula of 180 into n minus 2 divided by n is going to give us our answer for the one of the interior angles. And then we come down to, how do we find out what an exterior angle of the shape is? Well, that's pretty straightforward. When you think about it, all of the exterior angles added up to 360, didn't it? So for example, if I've got a three-sided shape dividing, let's just say it's an equilateral triangle, because it could be any triangle, but just for the sake of argument, it's an equilateral triangle. Dividing 360 by the number of sides, which was 3, gave us the angle we were looking for. Let's pop down to the pentagon. We had 360. If we divide it by the number of sides 5, that will tell us that each exterior angle is 72. Well, I'm sure you got my idea. Now, if I want to know what any exterior angle for any shape is going to be, all I've simply got to do is divide 360 by the number of sides that that shape has got. All right, let's put this into practice real quick and see where we're going. Let's just say I have got I don't know, an 8-sided shape. So it's got 8 sides, okay, 8 sides. And I want to know what the external angle would be. Well, I know it's got 8 sides, and I know that all the external angles add up to 360, so 360 divided by 8 is going to take me straight there. Alright, so once we've done that, we know that each external angle will be 45 degrees. So we have a known external angle of 40 degrees, and we're trying to find out the number of sides. Again, we already know that all of the external angles add up to 360 degrees, so it's just a quick job of 360 degrees divided by 40 degrees, which is going to tell us that we're looking at a 9-sided shape, which is our nonagon. Another situation we can look at is, let's say we've got a 7-sided shape or a heptagon, so it's got 7 sides, and we want to find the sum of all the interior angles. Well, pretty easy job. We already know. If we know it's got 7 sides, it means that the number of sides n is 7. And we can use a quick formula where we're going to say it's 180 and in brackets n minus 2. Just replace the n with 7. That means we're going to get 180. 7 take away 2, that gives us 5. 180 times 5 will give us 900 degrees. So all of the angles in that shape is going to be 900 degrees. All right. The last situation we'll look at today is, let's say we've got a shape where we know that all of the angles inside the shape add up to 1260 degrees, and we're trying to find out how many sides this shape will have. Well, that's all right then. We know a formula that we've just used up here that basically helped us to find the total of all the angles in that shape. We can use it because this formula has the number of sides in it, which remains unknown. So we're going to use that formula to our advantage. We're going to say that we've got 180 into n take away 2 is equal to 1260. Okay, so this, if we can find n, then we can find the number of sides that shape has got. Well, a quick bit of arithmetic first of all. I've got 180 multiplied by this bracket, so I will divide by 180 to get rid of it real quick. So I will end up with n take away 2 is equal to 1260 divided by 180. So we get n take away 2 is equal to 7. Nice. Now it's just a quick matter of removing this 2 and bringing it on that side by adding 2. So I'll just bring my calculation over here just a little bit because of space, and I'm going to say that that's going to be n is equal to 7 add 2, which tells us that that's going to have 9 sides. Now, if you check the video on angles in polygons, you're going to see that a 9-sided shape, all the angles in it, adds up to 1260. All right, on this page, I've got quite a lot of work for you to do. Be a good idea to pause the video here. It's already been 20 minutes. Have a go at some of these questions. Don't do them all. Just have a little, have a go at a couple from 3, from 4, all the way to 8. Make sure that you understand it very well. And then when you're finished, the answers will come on the next page. So pause the video here and have a go. Here are your answers.